Hi everyone, let's talk about voltage dividers. To begin, let's just start with a really simple series circuit. And the question is asking me what is voltage across R2. Now, since this is a series circuit, I know that my current that comes out of my source goes through both of these resistors. So I know in a series circuit that IT equals I1 equals I2. Okay, so we're going to use that to help us find the voltage across R2. I also know that V equals IR. So for my source voltage, I know that 9 volts equals I total plus times R total. In a series circuit, I also know that R total is the sum of R1 and R2. So in this case, I know that RT is just 3 plus 3. I know my total current is 1.5 amps. So if I know that IT is 1.5 amps, that means I have 1.5 amps going through R1 and 1.5 amps going through R2. So if now I want to consider what the voltage is across, what the voltage drop is across R2, what I need to do now is use, again, V equals IR. V2, in fact, equals IR, I2 times R2. But in this case, we know that I2 equals IT. So I know here that V2 equals 4.5 volts. Now I know we weren't asked to do this, but let's find the voltage across R1. Well, the last thing we need to remember is in a series circuit, we know that Vt equals V1 plus V2. So here I have all the rules for series circuits, and that have come in handy. Okay, so we know that then 9 volts equals V1 plus V2. 9 equals V1 plus 4.5. So V1 has to also equal 4.5 volts. Now I'm going through all of this. Okay, just to sort of put you in the mindset that we probably could have figured this out even without doing all these calculations. So logically, if I know my source has 9 volts and I additionally know that my resistors have an equal value, well, wouldn't it split up the voltage evenly? Doesn't that make sense? So of course I'm going to have 4.5 volts across R1 and 4.5 volts across V2. R2. So I'm just going to take a minute now and I want to show you how to set this up in Tinkercad. Okay, let's just start a new thing. So when I go to my dashboard, I'm going to have something that looks like this. And what I want to do is click on Circuits, and then I want to create a new circuit. So what we're going to do is emulate that voltage, that series circuit that we just saw. So what I'm going to do is drag out a breadboard and I'm going to rotate it while I have it highlighted. Okay, we can call it breadboard. Not a big deal. And then what I'm going to do is bring out a 9-volt battery and hook it up. So I'm going to take my negative lead, I'm going to put it on my ground rail here. And what I want to do is drag in 2 resistors. Okay, before we go on, what I want to remind you of is that all of these rails horizontally have the same voltage. So these 5 little holes all have the same voltage as each other. There's a break here, so they don't have the same voltage as these 5 holes, but they do have the adjacent holes in common. So what I've noticed here is that the bottom terminal of this resistor is electrically connected to the top terminal of this resistor. So I don't need to put any wire between those. But the top of this resistor at this point doesn't have power yet, so I do have to connect power to this set of 5 holes. Let's make this red. Okay, and then we are going to ground the bottom of this. So make sure you're not doing it from here because this rail is not electrically connected to that resistor, but this rail is. So any one of these holes I can click and make sure I've grounded it. Okay, so I have set up my circuit that we just saw, and I'm going to start my simulation. But what you'll notice is the time is passing and nothing's happening. We can't see anything. And that's because we actually, in this case, we need to measure something. So what I'm going to do is I'm going to drag in this multimeter. And I'm going to make sure that it's set in voltage mode because what I want to do is measure the voltage across R2. So the way I need to do that is my meter also has a negative lead that I need to ground. And then I can pick any point on this, circuit to find the voltage of in comparison to ground. And you'll know that in our circuit, the thing we were interested in was, the value right here. So from the bottom of R1 to the top of R2. And let's leave that green because it's not going to, it's not power. We're just taking a measurement. So now when I start my simulation, I should see the output voltage. So I'm going to get you guys to do that.